Folks. In this demo, we'll cover our automation solution for migration of service provider networks from MPLS LDP to segment routing. Uh, let's first start the migration and then we can quickly discuss different components of the solution. So let me quickly jump into the migration itself, start it, run all. So these are the different steps. Basically, I'm running all of them. So let's quickly jump into the components itself, look at the different components. For implementation of this solution and performing demos, we have used virtual environment, which is running in two different VMs on UCS C240. One VM is used for simulating customer network using Cisco Viral, which is simulating provider core as well as provider edge using virtual XR routers, and then customer edge routers are virtual iOS routers, and similar and again we are using virtual traffic generators as well for generating L3 VPN as well as global internet traffic. Other VM is a Ubuntu VM where I'm running different tools used for this automation. Uh, Most of the automation of the migration configuration is done using Ansible. We have mainly used XR modules of Ansible, which I'll show you, which some of them I'll show you as a part of the demo itself. For generating automated mobs, we have used Jupyter Notebook, which will also act as a front end for mob execution. Jupyter Notebook is an open source web-based application that allows you to create shared documents that contain live code, do visualization as well as the text-based outputs. Then using Jupyter Notebook, we can run all the mobs using a single server, and end user just needs web-based link to access their automated mob. Other advantage of Jupyter Notebook is that we can log all of the execution output in HTML or a PDF format, which can be later shared for troubleshooting and validation of migration steps. So that I consider is a very good advantage of using Jupyter as well. I'll show you one of such recorded mob during the demo. Also, we are using TextFSM and Pandas mainly for CLI parsing. Using TextFSM, we convert CLI output to a JSON format and then use Pandas to convert that JSON output into a table format. Why the table format? The main so table this is mainly used for end user experience. So where they will see a structured table output, which will help in easy validation of steps during the mob execution. Also, during the migration, we'll need to have a continuous feedback from the network. For this, we are using streaming telemetry to see how the end applications like L3 VPN or global internet traffic is behaving. To implement telemetry collection, we have used Cisco Pipeline, and then for storage of the telemetry data, we have used InfluxDB, which is an open source time series database, and similarly open source tool called Grafana for the visualization of the data. Let's quickly run into show you the migration flow. So basically, we convert first SR core of the service provider network to SR plus MPLS, then convert one part of the network to L3 VPN or plus SR, and then SR only, then global internet to SR, and then eventually the other part of the networks to SR only. Why we are using or why we are executing it in the mop into a different parts of the network individually? Because we want to, because in a big service provider network, we can't always execute or make changes across the network. So the how we have developed this mop is that it can be executed in different parts of the network individually without impacting the traffic in the other parts of the network. So that's other powerful advantage of using this automated mop. Then this is the traffic flow. So we have different traffics going through the network. This is on the simulated network which we have used for the demo. So L3 VPN is shown in a blue, and the global internet traffic is shown in the red flows. So let's quickly jump into the demo itself. First, let's look at the Grafana web page. So this is the Grafana page where the telemetry feed is coming in. So you can look at all the interfaces through the core which are sending traffic. So these are passing traffic for global internet as well as L3 VPN. So anytime there is a traffic drop seen, you can always execute that backup mop. So this is another backup mop. So anytime you see any errors in the mop, or you want to roll back the whole of the migration back, you can use this mop as well. So both to convert and roll back, we have the automation. So this is what you see. This I already started at the start of the demo. This is already running. The parts which are shown highlighted red are being run as we speak, whereas the parts which are not highlighted are already ran. So for example, let's look at go to this one, validate SR. So you can see it's currently running and as we speak. So it's moving to the next step now, which is show command collection for the XR. As you can see, it's continuously running. Let's look at go to the first one. So this is the table of content. You can click on any of them and go to the first one. So if you look at this, so first one is the Ansible playbook, basically run to collect the show command, which is show MPLS interfaces. Let me close the table of content so it can be viewed on the full page. So this is where show MPLS interface. Similarly, we are connecting show MPLS forwarding. Once the show command is collected, we convert it into a JSON format, which is stored in the file, and then from that file we convert that into a table format. So this is how the table format looks like. For example, show MPLS interface. This is the table format for all the interfaces on router P1, and similarly this is the forward table format of the show MPLS forwarding. Why the table format? Because it's easy to validate using a table format. As you can see, quickly look at rather than the CLI, you can quickly look at, okay, this is the my prefix, this is the byte switch. You can compare it. For example, once I go to next step, for example, the next step is to configure segment routing on the core boxes. Once I configure that, if you look at so this is how the segment routing was configured. And once you go in and look at the next step to do the validation, here in a validation step, you can clearly see that now I can see the SR based labels as well. So let me show you the recorded one as well. So that is still running. So this is the recorded one. So this is stored in HTML format. So if you look at this recorded one, it's all the steps similarly. And if I go to the last step, here in the last step, I've removed MPLS LDP from all the routers, and you can see that the table format for the output now shows that there is no LDP based labels. All of them are SR based labels. So this is the biggest advantage of using automated mop or Jupyter notebook, that you can have a recorded version of all the executions and store it for later troubleshooting and looking at the output. So that was so this is still running. Let's look at the the web page or a GitHub page for this. So this GitHub page have all the details about our solution, including the component details, which I've already discussed as a part of the demo. Then for a demo purpose, the usage, how to use for the demo, and also the installation and all how the installation can be done for the demo purpose as well as the production. If you want to use this automation in the production. So yeah, let's quickly look at one of the Ansible playbooks as well. So for example, these are the Ansible playbooks for different steps, which we already discussed as a part of this demo, or I showed you on the Jupyter notebook. So for example, SR enable. So this is the SR enable. So this is the task which is in a YAML file or Ansible YAML file. I'm calling this template. So all the configuration is being templated in Jinja 2 template format. Jinja 2 templates are for generating templates for network configuration used in this migration. So if you want to look at the template for initial configuration of in the core, so this is how it is being done. Similarly, if you look at If you go here, these are the defaults, or the variables which are being used for. These are the prefixes for the for this. So yep, that was pretty much for the demo. And if you have any question, please reach back to this team for more details. Thank you.